Hello everyone, and welcome to our first video on Unit 1.8, which is on the algebra of functions and function composition. So let's start off with algebra of functions. Now we have a definition to start off. What is the algebra of functions? So let f and g be continuous, or be functions, and define f plus g, f minus g, f times g, which, by the way, some textbooks write fg with an implied multiplication right there, but it's your call to do however you want to write it. And then f divided by g, as we denote it as f plus g of x is f of x plus g of x, exactly what you would expect when you take the two functions add together. You add the functions individually. The function defined by f minus g of x is f of x minus g of x. Once again, exactly like we would think. F times g of x, exactly like we would think. F of x times g of x. And then f divided by g of x is also f of x divided by g of x. So it's nothing really new. All we're doing is we're just saying we can combine functions together. And so the main thing, though, this gets into the question about domain when you have multiple pieces. So the domains of f plus g, f minus g, f times g, and f divided by g are the intersections of the domains of f and g. However, with the additional stipulation that we must exclude values that make g of x equal to 0 for the quotient function. So let's talk about how we find domain in these cases. So let's underline this with blue. So the example we're going to follow along with the procedure is we're going to try and find f plus g of x along with its domain, where f of x is equal to 1 over x and g of x is equal to x squared minus 3x. Now, what I'm going to do just off the bat, because it might be important later, I'm going to write down the factorization of this just so that we have it for reference. So step one is going to be find the function, but do not simplify it. Do not simplify it. And we'll explain, oh, how did that turn into an arrow? Whatever. I will explain why in just a moment, but the key thing, don't simplify your function. In fact, sometimes you don't even need to, but either way, in this example, and I'm going to rewrite the definition each time just to practice it, just to memorize it. So this is f of x plus g of x. So f of x is 1 over x, and g of x is x squared minus 3x. I could write it in its factored form, but that's not going to be necessary. It wouldn't be wrong to do so, though. Now, as it stands, I could simplify this by finding a common denominator, being x, and then multiplying this by x over x and this by x over x, which is what I'm going to do. But at this juncture, that's all I need. Now, step two is to look holistically at the function to find the domain. So I'm going to rewrite the function now without writing so f plus g of x is 1 over x plus x squared minus 3x. And so I'm looking at it holistically, and I look at this first piece and say, well, from here, I know we have x not able to be equal to 0, because if x was equal to 0, then we'd be dividing by 0, which is undefined. But the secondary piece here, this has no issues because it's just a polynomial. It's just two terms, and you can plug in whatever you want for x, and it'll exist. So now, if you know how to write your interval notation for your domain right off the bat, that's excellent. But what I'm going to do is I'm going to draw a number line. And after time, you don't need to do this very often, but here it is. So from the orange, we know that this is plucked out, and then we know that everything else is fine. So the domain is in particular negative infinity to 0, parenthesis, union, parenthesis, 0 to positive infinity. And now what we'll do is we'll simplify our function. Now that we've taken care of that, now we'll simplify our function. So f plus g of x is going to equal 1 over x plus x squared. Leave a little bit of space and write multiply by x over x so that we get a common denominator. And then don't forget about your minus 3x and multiply that by x over x to get a common denominator to give us our final answer that f plus g of x is equal to 1 plus x cubed minus 3x squared, all divided by x. Or you could write it as, or If you really want to write in descending order, x cubed minus 3x squared plus 1 divided by x. So that is our answer in conjunction with probably this. Because the questions usually ask you for the domain and for the function. Now, if it doesn't say you don't need to, if it doesn't say to simplify, you don't necessarily have to. And if it does mark you down for that, please let me know, and I will give you full credit back. It should say that it wants it to simplify if it wants it simplified. Now, question: why didn't we simplify at the beginning? What was the problem there? Because looking at this function, this version of the function, and this version of the function, they seem to be roughly the same. Like they both give me the same domains. If I try and look at both of them holistically, I'll get the same domain. Well, I want to look at this example in particular to highlight that issue and why I don't simplify until the very end. Oh, I just want a line. There we go. Given that f of x is equal to 2x minus 6 and g of x is equal to x over x plus 2, find the domain of f over g. So let's start that process on the left here. So f over g of x is defined as f of x divided by g of x, which in this case would be 2x minus 6 all divided by big bar. In fact, I'm going to use a big bar because this is going to be a complex fraction, i.e. fractions within fractions, and then over x plus 2. So on the side here, we're going to have a little note. Well, not a little note, it's a pretty large note. So as you know, when you divide by a fraction, you flip and multiply. So if we were to simplify first, we would get that f over g of x is equal to, when you flip and multiply, it'd be 2x minus 6 times x plus 2 divided by x. And that would be it simplified. I mean, yes, we could probably FOIL this out too, but just for like, we don't need to do that. We could, why not practice your algebra skills? But either way, this looks like the only issue would be x equals 0, meaning that the domain would be negative infinity to 0. Like it would be this precise domain. So, but that's not true. So by looking at it in its simplified form, the only problem that we encounter is just this x. But remember, and you might be thinking, Phil, that's the same function though. I just did a little bit of algebra. And yes, but you got to remember the definition. So, but by the definition, f divided by g of -2 would be defined as f of -2 divided by g of -2. And what's f of -2? Well, f of -2 would be 2 times -2 minus 6, which would be -10. So no problem there. But g of -2 would be -2 divided by 0, or -2 plus 2, which would be -2 divided by 0, which is undefined. Sad face. So this is that little quote unquote side note. So let's talk about it one more time before we move on to actually doing this problem correctly. So by the definition, f over g of -2 should be defined as f of -2 over g of -2. And f of -2 has no issues, but g of -2 doesn't exist. So how can I take -10 and divide it by something that doesn't exist? That is why we have to be careful. So now we'll start so we won't simplify first. We'll wait until the end to simplify. So first we got to look at this piece right here. This can't equal 0. Since the denominator can't equal 0, we have that x over x plus 2 can't equal 0. Now you can multiply both sides by x plus 2 if you really want to, or you can just treat this as 0 over x plus 2 and realize that the only thing that will happen is x can't equal 0 to solve this equation. Feel free to look at videos on how to solve rational equations if you're stumped on that one. But the other thing that's coming up is from down here. From here, we need x plus 2 not equal to 0, as we explained down below. G of negative 2 won't exist because you'll be dividing by 0 in the small denominator, the denominator within the denominator within the denominator. So x can't equal negative 2 as well. So those are the two values, and if you know how to draw your interval notation, excellent. You're doing excellent. But if you're still struggling with it, this is where you can draw a number line to help figure it out. So 2 is a no, negative 2 is a no-go. Oh, from the green, not from the blue. Negative 2 is a no-go, and 0 is a no-go. And everything else, though, is fair game. So now I will simplify it by just flipping and multiplying to write it as f of x, sorry, f over g. F over g of x is equal to 2x minus 6 times x plus 2, all divided by x. You could FOIL it out if you really wanted to, but not really needed. And then the domain is negative infinity to negative 2 parenthesis union parenthesis negative 2 to 0 end parenthesis union 0 to positive infinity, all with parentheses. So that is our answer. That is why you want to be careful and not simplify first, because every once in a while you lose out on a bit of information. So let's do some examples now. If we're going to have three different functions labeled f, g, and h, and we're going to find either the following functions or the following values. If we're finding a function, also determine its domain. So f plus g of x, by definition, would be equal to f of x plus g of x. And so that would be 3x squared plus 21x plus g of x. The parentheses are unnecessary, but I do like to show them to say like that's from f, and then g is the square root of x plus 5. And so there's no issues here. We're going to stop and not simplify. Granted, we actually can't even simplify. There's nothing to simplify, but regardless, we look at this thing holistically. This has no issues. I can plug whatever I want into that, and that nothing will happen, though those first two terms. But this third term, this radical, this has issues. We need the inside, x plus 5, to be greater than or equal to 0. If not, then this thing will not produce a real number because it'll start doing square roots of negative numbers, which lead into the complex plane. So x, it must be greater than or equal to negative 5. And there's no simplification possible. So we will just box in the answer with a slanted one. Of course, that's what I wanted. Like that, and we're good. And so from here, we could draw a number line. And once again, if you know how to do it without the number line, kudos to you. Go ahead and just keep skipping this part. But we're talking about all the values to the right of negative 5 because we're talking about greater than. So negative 4, negative 3, and so on and so forth. So writing that as an interval, that's bracket negative 5 to positive infinity parenthesis. Next one, f times h. By definition, that is f of x times h of x. So that would be 3x squared plus 21x times 5 over x. And once again, here's an example of why we don't want to simplify first. And I'll do that as an aside in just a second. This has no issues, but this has an issue at x equals 0 because we cannot divide by 0. So on a number line, 0 must be plucked out. Forgot to label it 0. and everything else is chill. Everything else is fair game. Meaning that the domain should be parenthesis negative infinity to 0, union 0 to positive infinity, all with parentheses. So, you remember how I said that I didn't end up using it for that one, but this one, 3x squared, just going to notice that this is 3x times x plus 7 because there's a factor of 3 and x that can be factored out front. And then, lucky for us, to simplify it, the x's cancel. I should have highlighted this example like that, but either way. And so we end up with f of x equaling 15 times x plus 7, or f times h of x is equal to 15x plus 105. Yes, plus 105. Though I imagine you could probably leave it in the factored format, the above. So this one here, that would probably be fine, but this probably looks a little bit nicer, I guess. And so if you had simplified first, you would have said, oh, well, there's no issues. This is just a nice line. This is just a nice line. So it's defined everywhere, but it's not. When you originally try and plug in 0, you get 0 times undefined, and 0 times undefined doesn't exist. Anywho, let's continue it, and then that'll be the last bit for this video. We're going to continue that example because there's a couple more questions I wanted to ask. And so it says also find h minus g of -1 and then g over f of x. So h minus g. I'm going to mention we could find h minus g, so we don't need to find h minus g of x in order to calculate this. Yes, we could. We could totally do it. We could find it and do h, so 5 over x minus the square root of x plus 5, and that would be fine. But what if those things are really, really complicated and convoluted together, and there's a lot of simplification, unnecessary stuff? That'll be especially relevant when we talk about composition functions later on in this unit or this section. But we can just appeal straight to the definition. This is by definition h of -1 minus g of -1. And so I can plug those in separately without having to actually find the function. It saves me a little bit of writing. So this ends up being 5 over -1 minus the square root of -1 plus 5. That's going to be -5 minus 2, which is -7. And since we're not being asked to find the function, we're just being asked to find the value, we're done. So just keep that in mind. You don't have to find h minus g of x first. You can, if you're just being asked to find a value, you're done. Last one, this one's the tricky one, but a very, very fun one. By definition, this is equal to g of x divided by f of x, which is going to be the square root of x plus 5, all divided by 3x squared plus 21x. So that, we look at it holistically. There is nothing that can be simplified here. There's nothing really we can do. So this is going to be the answer. But still look at it holistically before even trying to simplify. And looking at this, we know that x plus 5 needs to be greater than or equal to 0. Otherwise, we'd be trying to plug in negative numbers into a square root. So x needs to be greater than or equal to -5. And then from the denominator, we know that 3x squared plus 21x can't equal 0. And so that would be to say we can factor this. That's 3x times x plus 7 can't equal 0, which means that x can't equal 0 from the 3x equaling 0, and then x plus 7 can't equal 0. And that means x can't equal -7. However, I want to comment on something because this is a little bit of a tricky situation. This right here, this second one is, mathematicians love to say, they love to say, vacuously satisfied. It is vacuously satisfied. This is already taken care of. by the blue. So this is already taken care of. We can't even plug in -7 because then that would make the numerator undefined. So this thing is already taken care of. I can show it on the graph as well. So if we were to look at a number line graph, here is -5, here's -7, and here's 0. It's not drawn to scale. From the red, we know we have to take out -7 and 0. And then from the blue, we know that we have to be greater than -5. So this is automatically taken care of by the blue. It's automatically taken care of for us. So we don't even need to worry about it. We'll just kind of ignore it. So anyways, now looking at the number line in front of us, that means that our domain is bracket -5 to 0, parenthesis, union, parenthesis, 0 to positive infinity, end parenthesis. And that will do it for this one, and I'll see you guys on the next one.